This video is titled, What is the difference between strong and weak acids? So we will look at some common misconceptions. We will also look at, obviously, what is a strong and weak acid. We will then look at the different ions that are in solution with acids and look at how the concentration of those ions impact what we call the pH. This is the pH scale, and I'm just really quickly going to touch on this because lots of times when we refer to the pH scale, we talk about increasing the pH scale. Okay, people think that increasing the pH, we are actually making things more acidic, and it's actually the other way around. So if you look down here at your 0, 1, 2, these are some of your most highly acidic things like hydrochloric acid. Okay, very, very acidic. Now, hydrochloric acid is actually a strong acid. As you move up towards the neutral, which is pure water, we then start to look at some weaker acids. Okay, so already you can relate the pH scale to strong and weak acids in the sense that strong acids are really low down the bottom. Remember, the lower the number on the pH scale, the closer to a pH of 0 you are heading, and that's where your strong acids are. And you'll see something like hydrochloric acid is the acid in your stomach, very strong. We come on to all of these other acids here, so lemon juice, orange juice, which contain citric acid, vinegar, which contains ethanoic acid. They are weak acids, and you will notice that all of these here you can ingest, so you can take all of these into your body, and that's because they're weak acids. Okay, so just remember, on the pH scale, if we are talking about increasing the pH number, we are looking at heading towards the alkali end of the scale. If we decrease the pH number, we are looking at heading towards the acidic end of the scale. So some common mistakes that students make, and to be honest, it is kind of due to the fact that you are taught about concentrated and dilute before you were taught about weak and strong acids. So concentrated and dilute kind of go hand in hand. So before we've talked about concentrated acids and dilute acids. A concentrated acid is I guess you can think of like an acid in like its raw form. It hasn't had any water to added to it. Okay, a diluted acid is an acid that has had water to it, and you dilute it. Okay, however, when you talk about strong and weak, you're not talking about any addition of water. You're looking solely at the, let's say, the concentration of H plus ions. Okay, and I'm going to come on to that in a minute. But the difficulty is that you do want to keep concentrated and dilute and strong and weak separate in terms of their definitions. However, you actually can have a strong dilute acid, and you can also have a concentrated weak acid, and that's where it gets even more tricky. Okay, so for now, I just want you to kind of focus, particularly on this video anyway, I want you to really just focus on concentrated and dilute going hand in hand, and then strong and weak going hand in hand as well. So concentrated and dilute is where you're looking at the addition of water. Strong and weak acids are how we categorize acids based on their ability to what we call dissociate in water, which I'm going to talk about soon. So a concentrated acid and a dilute acid, I'm just going to talk about those really, really briefly. So a concentrated acid is where, let's just say I've got a beaker, okay? So I've got a beaker here, and I've got a beaker here, okay? So a concentrated acid, I'll just draw these, lots of acid particles. This is really, really basic. In a diluted acid, I would have my acid particles, but I would then also have my water particles. Okay, it's been diluted. So the more water you add, the more diluted the acid becomes. The less water you have, the more concentrated the acid is, and you can have it to the point where you have just got acid particles within your beaker. Okay, so that's concentrated and dilute, and that's kind of the terms that you would have been taught at kind of year 7, in year 8 and year 9. Okay, and the reason that students get it the reason students then confuse strong and weak is because sometimes teachers may have wrongly referred to something concentrated as something being quite strong. So if you think of like a glass of squash, for example, and you've added loads and loads of squash and not much water, somebody might say to you, oh, that tastes quite strong. And there lies the misconception where we think that strong and weak and concentrated and dilute are directly associated, and there is a crossover, but in the purpose of this video I want you to keep concentrated and dilute very separate from strong and weak for now. Okay, so a concentrated acid, lots and lots of acid particles, no or very little water particles. The minute you add water to an acid, you are diluting it. Now let's look at strong and weak acids. Now I just want you to have a look at the fact that we've got H plus ions here in both of them, in both of these equations, and I'll come on to what these equations are. So all acids will contain H plus ions. It's the acidic ion, just like how all alkalis, okay, contain OH minus. Okay, but in terms of strong and just in terms of acids, you are only looking at H plus ions. Okay, now the minute you add a acid to water, okay, you are going to see the ions within that acid, what we call dissociate. Okay, I'll just put that word there quickly, dissociate, or ionize. Similar word, they have the same meaning, two different words, dissociate, ionize. So the minute you add HCl, let's start with the strong acid. The minute you add HCl into water, we have lots of H plus ions around and lots of Cl minus ions floating around. If we look at ethanoic acid, you would actually have two ions. Again, you would have your H plus ions. That is what makes an acid. And you'd have what we call ethanoate ions floating around as well. So all acids do that, whether they're strong and weak, they will start to dissociate or ionize the minute they go into water. Okay, the difference is, and again, I'm just going to tidy up all of this. Okay. The difference is that strong acids, and that's what I'm going to start with first of all, okay, strong acids will completely ionize. Okay, that means that this molecule here of HCl will completely ionize or split up into H plus and Cl minus. Okay, so the minute you add HCl, remember HCl, you can call it a molecule, you add those molecules to water, the second you drop it into water, it completely ionizes. So every single molecule splits up into a H plus ion and Cl minus ions. So you would have, let's just say beaker, in there you'd have loads of Cl minus and loads of H plus. You wouldn't have any HCls, okay, you'd have it completely ionized. If you had a weak acid, however, okay, in a weak acid, we do have it splitting up into its two ions, but it does not completely ionize. Okay? It does not completely ionize. So therefore, and I'll just add arrows, so this is for this. Okay? If I drew a beaker for your weak acid, rather than seeing all of the ethanoate ions and the hydrogen ions, you'd actually still see, this is a really bad drawing, this is obviously not what it looks like at all, but it's just giving you an idea. You would actually see some of the molecules of ethanoic acid still present, okay, because it does not completely ionize. Only some of these molecules split up and turn into these, not all of them, which is why you still see some of these ethanoic acid molecules in the solution. That is the difference between strong acids and weak acids. Strong acids will completely ionize in water. Weak acids do not completely ionize in water, and that is it. That is the difference between a strong acid and a weak acid. Okay, now I'm just really quickly going to look at the pH scale and concentration of H plus ions, something which you do need to know. Okay, you will see here that the pH value is increasing by 1 each time. And you should notice that over here we are dividing, that's a 0.10, we're dividing it by 10 to get 0.010 and so on and so on. Okay, as you what we call dilute or divide the concentration of something by a factor of 10, you increase the pH value by 1. Okay, so I'll say that again. So I've got here the concentration. Okay, concentration of H plus ions in solution. Remember, moles per dm3 is a concentration unit. I've got the pH value here, each time increasing by 1. And what I will write actually is that means we're becoming less acidic. Remember, as you increase the pH, you're coming away from the acidic end of the scale. You are becoming more neutral and then in turn onto more alkali. Okay, so I've got my concentration of H plus ions, my pH value increasing. Let's say I started with a 0.1 concentration of H plus ions in moles per decimeter cubed. If I divided that by 10 or diluted the solution by a factor of 10, I increase the pH value by 1. If I then in turn dilute it by a factor of 10 again, I increase the pH value by 1. Okay, so really let's just write this out for you. So as the concentration of H plus ions decrease, you increase the pH. Okay, so the more H plus ions you have in solution, the lower the pH value. Okay, so remember these numbers here, and this is, I think, the most difficult concept of strong and weak acids. But you look here, this is a very, very small number. So a small concentration of H plus ions, a higher pH. A larger concentration of H plus ions, a lower pH. Okay, so the more H plus ions you have in solution, the lower, more acidic the pH value, which is why strong acids which completely dissociate in water or completely ionize in water, that means that they have lots of H plus ions in the solution, so therefore their pH is very low. When you looked at weak acids, remember weak acids were coming more towards the neutral part of the pH scale. Well, they do not completely ionize in water. A lower concentration, like we're looking at here, a lower concentration of H plus ions, so therefore a higher pH value, less acidic. Okay, so don't worry if you've watched this video through once and it's still really tricky. Strong and weak acids are really, really difficult, and you look at strong and weak acids more at A level, and even so, even then it's still quite a difficult concept. The two main things you want to take to this video are the difference between a strong and a weak acid, which is a strong acid will completely ionize in water. A weak acid will not completely ionize in water. You then want to always be able to relate H plus ions to the pH scale, and that is as the concentration of H plus ions decrease, you increase the pH and make it less acidic.